This says below are 3 dot plots of the proportion of tails in 20, 60, and 120 simulated flips of a coin. The mean and standard deviation of the sample proportions are also shown for each of the 3 dot plots. Match each dot plot with the appropriate number of flips. Clearly explain how you matched the plots with the numbers of simulated flips. So remember, there's 20, 60, and 120. So if you will go to page 2, you'll see the plot 2, and then go to page 3, and you'll see the other dot plot. Now, what you should be looking at here is how spread out these are. What is the variability of the sample proportions? That's what you're looking at. And we know that as the sample size increases, what happens to variability? It decreases. Good. So all we have to do is find the one that has the most variability, and that would give us the lowest number of coin flips, right? Because that's the least number of coin flips, so the variation is going to increase. Or you can look for the least amount of variation, and that would be the greatest number of coin flips. Okay, so if you flip through page 1, page 2, and page 3, how would you describe dot plot 1, the first one? There's something else we can also look at here, right? Since it gives us a standard deviation, the smallest standard deviation is going to go with the highest number of coin flips, right? So dot plot 1 has a 46 thousandths. Therefore, that's the highest one, so it's going to be the sample size of 120 flips. Okay. Now, explain why we chose 120 flips on box plot 1. Well, there's 2 ways. Standard deviation is the lowest, and there's least spread / variability. Okay, that's all you have to do. Now, page 2, this is 64 hundredths, or I'm sorry, 64 thousandths. It's the middle one, so we're going to call it 60. Sample size of 60. Okay, why? Because it's more spread out than box plot 1. Okay, and it has a higher standard deviation. And a higher standard deviation. So box plot 3 only leaves us with a sample size of, was it 20? I think. And this has the greatest variability and highest standard deviation. Okay.